In this class, now I am going to explain you collisions. Students, in our daily life we observe many collisions which happens around to us. I give you an example which we observe in our daily life. We play carom board game. In that game, we hit that coin by the striker to send that coin into the hole of a carom board. That hitting a coin by the striker is an example for a collision. Like you observe many collisions in our daily life. Now I will give you the definition of collision in the physics language. See, in the physics we define collision like this. A strong interaction between bodies if it involves exchange of momenta is called a collision. See, a strong interaction between the bodies. Whenever the collision happens, there it involves some exchange of momenta takes place. Whenever the collision happens, some changes takes place between the bodies. Okay, so that changes will be momentum and kinetic energy. Momentum of a body will get by multiplying its mass with velocity, and whose kinetic energy of mv square. So here mass into velocity which gives momentum, and 1 by 2 mass into v square velocity square gives us kinetic energy, you know that. So before the collision and after the collision, if you observe, this momentum and kinetic energy must be conserved. Conserved means remains same, constant. So in whichever collision, this momentum of the system and kinetic energy of the system before the collision, after the collision is same, then such collision is known as elastic collision. And in some collisions we find momentum is same but kinetic energy is not same before the collision, after the collision. So such kind of collision is known as inelastic collision. Okay students, you got the definition of a collision, and here we have two types of collisions. One is called elastic collision, one more is inelastic collision. See, whenever the collision is occurred, some changes we observed in that system before collision, after collision. So here it involves exchange of momentum gets changes, and acceleration also. But if you observe all the system before the collision, after the collision, both momentum and kinetic energy are conserved, means remains same. In whichever system momentum and kinetic energy are conserved, then that system is known as elastic collision. In whichever system momentum is conserved but kinetic energy is not conserved, so such kind of system is known as inelastic collision. Okay, I hope you have got meaning of collision and the types of collisions, elastic collision and inelastic collision. Now let us go to the one dimension collision. One dimension collision. one dimension collision. See the students. See, before the collision and after the collision, if velocities of bodies are on the same straight line, then such collision is known as one dimension collision. See, there is a straight line. So there are two bodies, here one, here one. Here collision happened. Now moving on the same straight line only. Here, before the collision. Before collision. So this is after collision. So here collision occurred. See, before the collision, after the collision. Bodies are moving on the same straight line. Hence, this kind of collision is known as one dimension collision. So sometimes here, if this object or body hits this, so after the collision, so this may goes this side, this may goes this side. That is an example for two-dimension collision. In sometimes, so this after the collision, which breaks into the many particles, so which goes into the space. Okay, that is multi-dimensional collision. So, but here we have only one dimension collision. Observe this. Let us consider mass of this first object, body M1, which is moving in this direction with initial velocity u1. And here, let us take mass of second object M2, whose velocity is v2. Observe here, M1 is more than M2 and u1 is more than u2. And here collision occurred. Then after the collision, no changes will come in its mass, M1 only, and this is M2. So here, this first one is moving with velocity v1, second one is moving with velocity v2. So if it hits this, so here first one is moving with velocity v1 and second one is moving with velocity v2. Okay students, see here, as I said to you, in the elastic collision, momentum and kinetic energy both are conserved, which means that here before the collision, what is the momentum of the system? m1 into u1 plus m2 into u2. This is the momentum of this system before collision, which is equal to momentum after the collision, m1 v1 plus m2 v2. m2 v2. See, keep it aside and now go to the kinetic energy before the collision. m1 v1 square plus 1 by 2 m2 v2 square, which is equal to, here m1 v1 square before the collision, 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square, which is equal to, so here 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. So this is the kinetic energy before the collision. This is the kinetic energy after the collision. Both are same. Now from these two relations, I am going to find final velocity of first body and final velocity of second body formulas. How those two formulas are going to be generated, I explain you. So that final velocity of first body, final velocity of second body, we have taken as V1 and V2. We are going to find formulas for V1 and V2. Those two formulas will come from these two relations. See that. See students. Now bring it to the left side. When it comes to the left side, what do you get? M1 U1 minus M1 V1. Now transfer this one to the right side. M2 V2 already is there. When you bring this one to the right side, M2 U2 you will get. From this you can take M1 common. So here U1 minus V1 will be left. From these two you can take M2 common. V2 minus U2 will be left. Okay. So let it be some equation 1. Keep it aside. Now here also. So bring it to the left side and take M1 common. 1 by 2 M1. So here U1 square will be left. When it goes to the left side, V1 square, which is equal to, and when you transfer this one to the right side, 1 by 2 M2. So here V2 square. Here V2 square minus, here when it goes to the right side, U2 square will come. Okay students. Now see. Understood? This one now it came just, I have shifted this one to the left side and this one to the right side, and I took here M1 common, here M2 common. Here also this one I have shifted this one, and this one I have transported to the right side, and here I took 1 by 2 M1 common, here 1 by 2 M2 common. And in the next step, see, observe me how I am going to do. I am going to cancel this 1 by 2 and 1 by 2. M1 will be here itself. 1 by 2, 1 by 2 can be cancelled, and it should be written as M1 into, so here it is looking like A square minus B square. U1 plus V1 into U1 minus V1, which is equal to RHS M2 into here V2 minus U2. V2 plus U2 and V2 minus U2. Okay students. Now I am going to divide this relation with equation 1. Let it be equation 2. I am dividing equation 2 with equation 1. But here A square minus B square I have written as A plus B into A minus B. Now divide this with this. You get here M1 into U1 minus V1. So RHS M2 into V2 minus U2. Now, so here these two get cancelled, these two get cancelled. Now what is left here? Here it is M1, M1 also cancel, M2 cancel. What is left? U1 plus V1. Here what is left? V2 plus U2. Okay students, I think, I hope you have understood till here. Now here, to find V1 means velocity of first object after the collision. If you want to find V1, so here in this you have to eliminate V2. How do you eliminate? By making V2 subject here. Make V2 subject. If you shift this one to the left side, U1 plus V1 minus U2. You got V2. V2 you have to substitute here. If you substitute there, then what do you get? See here. Substitute here. M1. Send this one inside. M1 U1 minus M1 V1. So which is equal to M2 into V2 value. Write this one. Here U1 plus V1 minus U2, and here minus U2. Okay. Now simplify this. M1 U1 minus M1 V1. When you send this is inside, M2 U1 plus M2 V1, and here minus 2 U2 minus 2 M2 U2 you will get. Now make V1 subject. Okay. So bring this one to the left side. Send it to the left side so that you will get M1 minus M2 into U1, and transfer this one to the left side so that you will get 2M2 U2. So here M2 V1 is there. When it goes to the right side, take V1 common, M1 plus M2. Now V1 is equal to how much? So send it to the left side so that you will get M1 minus M2 by M1 plus M2 into U1 plus 2M2 by M1 plus M2 into U2. So this is the required formula for V1, is the final velocity of first object after the collision. Now to get V2 means final velocity of second object after the collision, what you have to do? You have to make here V1 as subject. V1. Now transfer this one to the right side. V2 plus U2 minus U1. This V1 should be substituted in place of V1 here, so that it will become M1 U1. Before V1 minus sign is there. When you substitute this value over here, signs will change. Minus V2 minus U2 plus U1. So which is equal to M2 into V2 minus U2. Okay students, now send this M1 inside. M1 U1 minus M1 V2 M1 U2 plus M1 U1, which is equal to M2 V2 minus M2 U2. Okay students, now okay, this one send it to the right side, and see here both are like terms. So in place of that you can write 2M1 U1, and when it comes to the left side students, so here what do you get when it comes to the left side? Minus of, see here, when it comes to the left side, minus M2 U2, here U2 is there. So here you will get M2 minus M1 U2, and if you take this one into the right side, you get M1 plus M2 V2. Now bring this one to the left side so that you will get V2 is equal to, so here 2M1, when it comes to the left side, here in the denominator place you have to write M1 plus M2, you know that, into U1, and from these two if you would like to take minus common, otherwise you write as it is. If you want to take minus common, you can, otherwise write like this only, M2 minus M1 by M1 plus M2 into U2. So this is the final velocity of second object. You got two formulas for V1 and V2. I hope you have understood this. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you one and all.